Hi, my name is Cambria Chou, and I'm a third-year PhD student in the Biomedical Sciences program at UCSF. I started my science journey as an undergrad at Brown University, where I worked in Gilad Barnea's lab on a team of researchers developing a genetic tool to study neural circuits in fly brains. After graduating, I moved to La Plata, Argentina on a Fulbright grant, where I worked in Jessica Arango's lab studying the regulation of voltage-gated calcium channels by the dopamine receptor D1R. Now at UCSF, I'm co-mentored by Diane Barber and Dan Wagner, and through this collaboration, I study intracellular pH dynamics during zebrafish neural crest development. Though we often think of the pH of cells as being constant, intracellular pH, or pHI, is actually a highly dynamic feature of cells that affects their behavior. For instance, pHI dynamics regulate cell behaviors including cell migration, proliferation, and epithelial to mesenchymal transition. I'm really interested in how pHI dynamics regulate differentiation and lineage specification. For instance, our lab and others have shown how pHI regulates the differentiation of stem cells, including mouse embryonic stem cells, follicle stem cells in the Drosophila ovary, and mouse intestinal stem cells. However, pHI dynamics during embryonic development, when abundant cell differentiation and lineage specification is occurring, remains largely unknown. I want to address this unknown by studying pHI dynamics during the development of neural crest, a conserved embryonic cell population that is highly migratory and that differentiates into multiple lineages that eventually become bone, cartilage, pigment cells, neurons, and glia. My hypothesis is that pHI dynamics play a critical role in neural crest cell development, regulating delamination, migration, and/or lineage specification. To test my hypothesis, I'm using a genetically encoded ratiometric pH sensor called MK-Florin, which I've introduced into zebrafish, an excellent model for studying embryonic development, given that they're genetically tractable and transparent. My preliminary data indicates that pHI is indeed dynamic during neural crest development, specifically during migration, with an increased pHI in migratory compared to pre-migratory cells. I'm really excited to continue this project, for instance, by manipulating intracellular pH in zebrafish neural crest cells and seeing the effect on cell behaviors. So thank you so much to the ARCS Foundation for funding me and my project. And if anyone has any questions, please feel free to reach out.